Okay, before I start the lesson for today, I just wanted to review how you would use the double distributive property in order to simplify this expression. So the first thing I want you to think about is the first term in the first set of parentheses. So we are going to take and we're going to multiply that by the first x. So we would have 3x times x, which is equal to 3. Remember, you have two of them here. The exponent rules. If you're multiplying by the same base, you add the exponents. We know that there's little ones here, so this is going to become 3x squared. I'm then going to take that 3x and I'm going to multiply it by 7. So that would be 3x times 7 is going to equal 21x. When I finish with that first term, I'm going to use the second term, 1 times x, and that's going to equal 1x, and then 1 times 7, and that's going to equal 7. Once we have finished that double distributing, then we are going to add and combine like terms. So these two terms are alike, so we would say that that would become 22x. So our final answer is going to be 3x squared plus 22x plus 7. Okay, you're going to need to know how to do this, the double distributive property, before you can do some simplifying of radicals, which is where we're going next. All right, so we are going to start talking about simplifying radical expressions. Now, before we do that, what is a radical expression? Okay, a radical expression is an expression that contains a square root. And the radicand, that is the expression under the radical sign. It is in simplest form if it does not contain any perfect squares other than 1. Okay, so we are going to jump right in with example 1. Now, every time we worked with square roots before, we always estimated those to 1 decimal place. Now we're not going to estimate those. We're going to break those numbers down and see if they contain a perfect square. So if I have 12, the square root of 12, if I break down the two factors, it's like prime factorization. If I can break down to two numbers and one of them is a perfect square, then we can simplify the radical. So 12 would be 4 times 3. 4 is a perfect square. So I would break that down as the square root of 4 times the square root of 3. What is the square root of 4? That would be 2 times the square root of 3 stays the way it is because that's irrational. And then you don't need that multiplication symbol. It's just like putting a number outside of a parenthesis. It's automatically understood to be multiplied. So we would simplify that as 2 square root of 3. So break it down to find a perfect square. Take the square root of that perfect square, and that goes on the outside of the number that's left as a square root. So if we have the square root of 3 times the square root of 15, well, there's nothing that we can do with those two numbers because there's no perfect squares involved. However, if we multiply those together, we would get the square root of 45. The square root of 45 can now be broken down into 9 times 5. So now I have a perfect square. So I could take the square root of 9 times the square root of 5. Square root of 9 is 3 times the square root of 5. It's always understood to be multiplication between those two. All right, what if we simplify with variables? So a second example would be to simplify with variables. Now, in order to do that, your variables have to have an exponent that is even, because it takes 2 to take a square root. So if I had 3 times 3, that would be 3 to the second power. If I had 3 to the fourth power, I can still take a square root of that number. So the example would be 40, x to the fourth, y to the fifth, and z to the third power. I would break that down. 4 times 10, because 4 is a perfect square. Now let's break down our variables. X to the fourth can stay the way it is because that's even. If I take the square root of that, there's 4 of them here, so to take the square root, I would end up with 2 of them. Y to the fifth, I'm going to break that down to be y to the fourth times y. So now I have y to the fifth, but I broke it down so that I can take the square root of y to the fourth. And then I would do the same with z. I can do z squared times z. Okay, so I broke down the ones that had odd exponents, so that way I can take the square root of those even exponents. Square root of 4 would be 2. I'm going to leave a little bit of space. What's left would be the 10. I can't do anything with the 10, so that has to stay inside the radical sign. X to the fourth, that's x times x times x times x. So that would be 1, 2, 3, 4. And it takes 2 of them to make a square root. So how many groups do I have? I have 2 of them. Therefore, this becomes x squared. I have 2 groups. Y to the fourth, it works the same way. Y times y times y times y. I have 2 groups of those. So that would become y squared. But I have 1 y left here. That has to stay inside because I cannot take the square root of that. Z squared would be z times z. And since I only have 2, that means I have 1 square root. So that goes on the outside. But I still have 1 left over, and that's going to go on the inside. All right. Next one should be rationalizing the denominator. Okay. All right. You can never, ever, ever have a square root in the denominator. So if I have the square root of 10 over the square root of 3, I have to get rid of that square root of 3 in the denominator so that I can rationalize and I can simplify this fraction. So just like fractions, you want to multiply both the numerator and the denominator by the same number in order to change this and rationalize it. So I am going to multiply by the square root of 3 and the square root of 3. Because I know if I multiply these two together, I'm going to get a perfect square. So you always want to multiply by whatever you have in your denominator. So now this is going to be the square root of 30 over the square root of 9. And the square root of 9 is 3. So I now have a whole number in my denominator. And I cannot break 30 down any further than that. 30 is the smallest. There's no factor of 30 that is a perfect square. So we'll try this one, the square root of 2 over the square root of 6. Now we want to rationalize that denominator, which means we want to multiply it by itself to eliminate it. So that's going to be the square root of 6 and the square root of 6. That now becomes the square root of 12 over the square root of 36. What is the square root of 36? 6. Now I'm going to break down that square root of 12 because I know I can do 4 times 3. The square root of 4 is 2, and we keep the square root of 3. Now because 2 and 6 can't do anything with the 3 because they're different, one's a radical and one is a whole number, but I can go in this direction and simplify. So this becomes a 1 and this becomes a 3. So my final answer, square root of 3 over 3. Okay, there is something called the conjugating. We need to conjugate the denominator. All right, so we have 2 over 6 minus the square root of 3. Now this is where that skill comes in that I showed you in the beginning, where you're going to have to use the double distributive property in order to multiply. So what we need to do is eliminate this square root of 3. So when you do that, you're still going to use the square root of 3, but we're going to flip the symbol. And I'll show you how that works. So this is going to be now 6 plus the square root of 3, 6 plus the square root of 3. So this is going to be 2 times 6 plus the square root of 3. And this one is going to be 6 minus the square root of 3 times 6 plus the square root of 3. Now I'm going to pull that aside and I'm going to show you how that works. Okay? So 6 minus the square root of 3 times 6 plus the square root of 3. Now use that double distributive property. I'm going to start with 6. So 6 times 6 is going to be 36. 6 times the square root of 3 is plus 6 square root of 3. You can't multiply those together and make 18 because one's inside and one's outside the radical. Now I'm going to do my second term. So that's going to be negative square root of 3 times 6. So that's minus 6 square root of 3. And then square root of 3 times the square root of 3 is going to give you minus the square root of 9. Now because one is positive and one is negative here, they cancel each other out. So I am left with 36 minus the square root of 9, which is 3. So my denominator now becomes 33. My numerator would be 2 times 6 is 12, plus 2 times the square root of 3, which is the square root of 3. Now I'm able to cancel 33 and 12 here because they both share 3 in common, but you have to be able to simplify the entire expression, and we're not able to do that because 2 is not a factor of 33. So when you have an expression in your denominator, then you have to multiply by the opposite sign so that that term will cancel each other out.